All right, hello and welcome to the this overview of Amundsen. So, what is Amundsen? Before we hop right into doing any type of demo with Trino and Amundsen, I'd like to kind of cover what is Amundsen. And so Amundsen is think of it as like a search engine that sits on top of all of your data sources. Now, why would you actually need something like this? Well, it really comes down to it. You're going to have, as you build out an entire data platform, you're going to have all sorts of tables that are going to be maybe, copies of maybe different versions or different copies for, various niche use cases that, let's say, other teams have. So let's say you have one team that, in a particular case, this Amundsen came from Lyft. So you have, this estimated time of arrival team, the ETA team. And so they have maybe this kind of representation of ETA. And so they have a table that's dedicated to that. Now, there's going to be a team that actually maintains one very, central use case ETA table, but then you're going to have maybe other teams that make copies of that for their own use case, or somebody has a job that's running that makes different copies and rarely uses it, but it's just needed it to be there in case there's a testing process that uses all these different versions of the ETA table, or somebody else goes and makes their own version of an ETA based on the data that they're pulling in, and it's not actually has anything to do with the original ETA team. You just basically get this smorgasbord of all these representations of what is called ETA. And so what can be confusing is these tables can be scattered not only across all these different data sources. Let's say you have some ETA tables that are sitting in Redshift, some that are sitting in Postgres, and you're trying to figure out as a data analyst, okay, well, which one am I actually trying to do for the context of the queries that I'm about to run? Usually you're going to have like one or two or three tables maybe that are really good candidates for the type of analysis that you're trying to run. But you're maybe looking through a list, according to Mark Grover, the creator of Amundsen, when he was working with these issues at Lyft. He was dealing with 200 or 300, on the orders of hundreds of tables that people were trying to look through to find the source table that they were actually trying to use in the analysis. So what Amundsen's trying to do is it's trying to kind of set a search algorithm out, something similar to PageRank that you would see in like Google, that looks at various signals. It kind of analyzes different signals about these tables or these bits on the data sources based on heavy access patterns. Who's querying these tables, and how often are they querying it? What kind of queries are they running? And is this an automated process, or is this a human being running these things? So all these different kind of source signals that come from how these tables are getting queried. And also it could be, what's the latest time this table has been updated? If there's a table that was copied, 5 years ago versus the table that is recently updated in the last couple minutes, more than likely you're going to be wanting the up-to-date table versus this very stale old data table, right? So what it comes down to is Amundsen is trying to gather all of this data about all these different sources that you could potentially be searching through, and try to make sense of what are the top tables that you should be finding. And this is ultimately a thing called data discovery, when you're a data analyst or even a data engineer trying to make ends meet and figure out where you're supposed to be querying data from. Amundsen is there to help you and trying to basically piece through all of these different tables. And so how does it do that? Well, you looking at the architecture is a pretty easy way to kind of get an idea of what it's doing. So you have all these different data sources, right? You have data that is probably in some operational database that needs to get pulled, that gets pulled out into Redshift, that gets, or maybe a Hive data warehouse, or you have, data that's sitting in a NoSQL database, let's say Mongo of sorts. And you ultimately have that data, representing all your tables and all of the information that you need to pull out. And they have all sorts of metadata about the different tables and the different pieces of information and schemas, basically, of what's sitting inside of that particular database, that data source. And so what Amundsen's going to do is it's going to use this framework that it has set out for developers or engineers that are building out this pipeline. They will be able to utilize this framework to pull the metadata from all these different sources and then export it into these two back-end data pieces for Amundsen, which Amundsen uses primarily Neo4j, which is a graph database. It holds a particular model of how it's essentially modeling the schemas and everything sitting in all of these different data sources. And then that data gets copied into Elasticsearch to make the data searchable. So when you look at these services that sit on top of this in Amundsen, you have a metadata service that can talk directly to Neo4j to directly pull out all of the tables and all the statistical information and catalog information that is needed during a query. And then when you're trying to search through this data, basically search in a little search box similar to what you would do for Google. And then you want to have a search engine like Elasticsearch backing that, so that you can ultimately find that data that you're looking for. And these two pretty much stay in sync across the board as you're pulling, as you update this information, you update both. And so this ultimately gives you the search and metadata service that backs the front end service that we'll see shortly. And it's going to be essentially this UI, this nice UI that you'll be able to go through and search around and see how things are set up in the back end. And so in a narrow view, we're just using Trino today for the demo that we're going to be running, and Trino will be built on top of a MinIO cluster. So it's ultimately going to be storing data in a data lake, and then Trino will be, having that metadata about that data sitting on S3 or on MinIO. And so ultimately we will run this, data builder ingestion framework to pull from the Hive Metastore, which Trino uses to reason about the data sitting in S3, and then pull that data out and store it in Elasticsearch Neo4j, ultimately being able to look through Amundsen. So let's, without too much more specifics about this, we'll hop into a little bit about the modeling and a little bit about how jobs and tasks are set up as we go along. But for right now, let's just hop right into the demo. So for the demo, you want to I will set up a link in the notes here, but you'll want to go to this Trino Getting Started repo that I have set up here, and I'll provide you a link in the description and or the notes. And then what you want to do from here is you'll copy this repo down, and you'll hop into this Amundsen folder. Now, under this Amundsen folder, we have a couple things to point out. So you want to look at this Docker Compose file. So what are the images that we're pulling up for this? I want to kind of just cover this real fast, just so you know what we're running. So we have Trino. These top four images are ultimately running, a basic Trino setup. So it's going to have a Trino coordinator, and then it's going to have a Hive Metastore and MySQL DB. And so Hive Metastore depends on this MySQL instance or this MariaDB instance in order to store the metadata about data that's getting stored in the fourth image, MinIO. And so data is getting stored here, and metadata is getting stored in these two images here, and then Trino is ultimately the runtime that is being used to query all of that. Anything below that, though, so you have those four top images. Any of these below here, we have Neo4j and Elasticsearch. As we kind of looked at before, we have this. This is what we were seeing here. So the first four images are sitting up here in metadata sources. We have our data ingestion framework that I'm going to be showing you in just a second. And then we have Elasticsearch Neo4j. And that's what these two images here are doing, Neo4j and Elasticsearch. And then the last three images down here are ultimately the Amundsen services that are running. So we have search service, metadata service, and front end service. So, these are ultimately going to be doing what I said. Amundsen Search is going to use Elasticsearch to ultimately give us that search capability. Metadata is going to give us the ability to query Neo4j to pull out different parts of the table. And I'll just do a quick aside here. This is what that model is looking like, where you're storing tables, columns, descriptions, column stats, user information, the Airflow DAG that was actually, so this is, whatever job that was ran to pull this data in, when was it run, and all these other bits of information that you can store inside that metadata service that and ultimately that's backed by that Neo4j image here. And then the front end is the UI that accesses these two search and metadata services here. So that should give you a rough idea of what we're aiming to do here. So obviously the first step is clone that getting started repo, and then go into the Amundsen folder. Like I had shown you up here, you'll change directory into this Amundsen folder here, and you should be seeing something along this line. And then you're going to want to run Docker Compose up. The Docker Compose is ultimately, and again, this is kind of a prerequisite. I do have it in the first page here, all the things that you'll need to install from Docker to make sure that you can run this demo. So ultimately, go ahead and install that, go into Amundsen, and then when you change directory into Amundsen, you're going to which we've done here already. If you look at where I'm currently at, I'm underneath my code repository under Trino getting started in Amundsen. Let me see if I can make that a little bigger. Clear this out. There we go. And then let's just go into where we're at right now. So we are underneath the Amundsen folder. And then, and ultimately you can see here, we have that Docker Compose file there. So as long as we're where that Docker Compose file is, we should be able to copy this Docker Compose up, -D. The -D just lets it run in the background as a daemon. And so we run that, and ultimately we should be seeing the Amundsen, all these images come up, right? So everything's looking green, and ultimately we should be able to even go to localhost 5000. Let me see, what's the first thing we do? Here, let's go to localhost 9000 is actually going to be your MinIO browser. So we can do that first, just to look in there. So you're going to log in MinIO 123, and sure enough, here we have a MinIO browser sitting right here, totally empty, of course, and so no data set in there yet. We'll come back here and talk about what we'll set up in the MinIO side. I also want to just showcase the front end of Amundsen. Let's go and just look at that. So this is what Amundsen actually looks like on the front end, and this is the kind of search, that Google search capability that sits on top of all of your disparate data sources. Now you'll be able to have this. Now we haven't plugged in anything yet, so it looks very empty, but it's just the idea that you'll be able to search over this stuff is pretty exciting to me, I think. So you'll clone down this Amundsen IO and Amundsen repository, and ultimately you're going to want to change directory into the data builder. So I've already done that here, and I've cloned that down here, and I've actually already run through all of these steps. What these steps are going to do is you're basically going to create a virtual Python environment here, and then you're going to run this activate piece here, install, upgrade, and basically install these requirements.txt. So if you look at the requirements.txt that's sitting inside here, this will give all the requirements needed for Python to basically have all of the libraries that is going to need to run this. And then what you'll do is run the Python 3 setup py install, and that is ultimately, if we look at, there's a setup .py in this directory here as well, and this will also run some of the necessary installations and dependencies that you'll need inside this virtual environment. I've already gone ahead and done this beforehand, so there's occasionally going to be some times where you need to make sure that you do Python 3, and there may be some debugging here or issues that you'll have to run through with Python 3 and dependencies and installations. But if that becomes the case, you can always reach out to us. And definitely find me on the Trino Slack, and I can help you through getting through some of these potentially tricky errors with dependencies. But once you've set that up, then you should be able to run a Python 3 on this script. Now, I'm actually not going to run Python 3 just yet. I want to quickly dive into what is in this. So let me syntax on. So let's go ahead and there we go. And so what we have here is we're importing a lot of these this framework from the data builder. You'll see a lot of these classes that come in from the data builder, and ultimately this is what is needed to pull that data out. At this point, let me go back to the diagram and talk about the data builder framework for just a second. So if you look at the data builder ingestion framework, you ultimately have what's called a job, and in the job you're going to have a task running. There are multiple, this ETL, which is the extractor transformer loader. This is going to be following a typical pattern that you see a lot of times in data engineering practices, where you're extracting data from a source, you're doing various transformations on it, and then you're loading it into the new source. And this is similar to what we're doing down here in the data ingestion framework with the metadata. So Mark and team followed the same pattern for their ingestion framework, and ultimately, within this task, that ETL pattern is followed here. Now, very commonly, you won't be using the transformer too often, at least in the more basic use cases. You're mostly just going to be pulling an extractor, which is, I'd say, the most important part, and then using a loader. And the loaders, because you're typically pulling into Elasticsearch and Neo4j, you almost always use the same loaders. So this actually becomes a lot simpler, because now all you really need to do is, for a particular single data source like we're doing today with Trino, you just need to know which extractor to use. And in our case, we're very lucky because there's already a Hive table metadata extractor that is used. And let me pull that up. You can automatically have the config, or this config is already laid out for you here in the Amundsen website of what properties you need to define. So particularly this where clause suffix. In our case, we're not going to use any where clause, so that's great. And then you just need to put the connection string. That's really all that comes down to, is we need to connect to the Hive metadata table, and we ultimately need to put any extra where clause suffixes, which we're putting nothing. So it's pretty straightforward. I shouldn't say straightforward. It's a little bit of a learning curve that you'll have to go through when you first set these up. But this is I think it's going to give you just a little bit of an idea of what's being set up here. So in our particular setup, in our extractor, and this is, by the way, the loader file, but ultimately in the definitions that we put in the loader itself, to call out the extractor, we set up this connection string. So the connection string is going to talk to ultimately MySQL, and it's going to basically define the user, the password, the host, the port, and the database. So in our case, we set all of that in that YAML file, but it's basically already pre-set up before. Again, this is all saved inside the repository. You just have to know the username, and the password's admin. The host is localhost, and the port's 3306. Database is going to be Metastore DB. That could be different depending on how you've configured all your Metastore stuff, but this is generally a common Metastore setup, and it's all done through MySQL. So as I'd kind of shown you before, we have these two properties here. We have the where clause suffix key, and again, this is the where clause suffix key that we're defining here. It's literally just an empty string. So we have that, and then we have the connection string. If you look at the end here, this connection string method that gets called, that's calling this method that we set up here. So ultimately, we set these two properties. The rest of this is actually just boilerplate code that I pulled from another example. So the Neo4j path, all this other Neo4j setup stuff, including the stuff that's sitting up here, these files, Neo4j, everything right here, that's all, and same thing with Elasticsearch up here as well. All of that's boilerplate that was copied from another example, and we really do not need to change any of that unless you're deciding that you want to have, say, replace Atlas for Neo4j and things like that. And that's where things could get a little more tricky, and you have to kind of dive in and learn a little bit more. But for the most part, you're able to copy and paste the original files that are the original job configurations to pull into Elasticsearch and Neo4j. So this is great. So the same thing comes here, the create ES publisher sample job. This is going to be ultimately the piece that pushes data to Elasticsearch, and then this is finally when we get to main. All you really end up running is you run that method that we called up there, run Hive Metastore job. That was the name of this this method here, run Hive Metastore job. So this portion here, this default job, you set that job config. You set the default task, which is taking the extractor and the loader. And again, we don't have to, by default, we're just doing a no-op for the translator. And then we ultimately run the default Neo4j publisher there. And then we published not only Neo4j, but also Elasticsearch in this method here. And we call both of those there. So we run the Hive Metastore job, which is basically publishing from Hive Metastore, pushing into Neo4j, and we launch that job. Then we create the publisher sample job for Elasticsearch, and ultimately we push that down and launch that job. That's all that's being done here in this script. It can be a lot when you're first jumping into this framework, but once you kind of played around with it and get your hands on the code yourself, it becomes a little clear that, oh, this is like a very standard set of operations. So now that we know what's going on here with this loader, let's go hop back and set up our actual data sources. So let's go down here, and in MinIO, we're actually going to set up a tiny bucket. And this is going to be so that we can, this has nothing to do with Amundsen. This is actually just going to be creating a location for us to write our data in Trino. And now we'll go in and create a schema. I'm actually going to pull up here. Going to pull up here we go. We have Trino up and running right now, and let me just show you that. Local host, and we have 8080. We have Trino up and running here. And so we actually need to create a MinIO schema. So if we look here, we can do a quick refresh, and it's just going to make sure that we do have that MinIO catalog set up there. And looks like, yep, just finished, and we still have that MinIO set up there. So let's go ahead and create the schema now. We're going to create a schema called Tiny, and we should now see Tiny set up there. And let's go create two tables. We don't want to just have an empty schema. We want to actually create some tables in there. So we're going to pull from a generated data source from our TPCH data source and create a customer table and an orders table. And so this will ultimately just be two tables sitting in here, but you can imagine if these, let's say you had 50 customer tables, which one's the right one to use? And this is where we start to really get into, what is Amundsen used for? So we saw these queries run through here on Trino side. If we refresh our MinIO, we now have data sitting here on MinIO. And ultimately, and I didn't show you the before thing, but the ultimate, this is the query that gets ran in the Metastore, in the loader itself. in the extractor that is being run by Amundsen, and it is getting out now these two tables with all of the column data and all of the table data and schema data and everything, and that gets ultimately pulled back into Amundsen to parse and put into Neo4j as well as Elasticsearch. So, so finally, now that we have data there, let's go ahead and run our data loader, which calls our extractors jobs, run those jobs, and then loads it into Neo4j and Elasticsearch. So this should run. Great. Let me see. Okay, yeah, it's okay. This is just saying that it's the index doesn't exist because it's a brand new ES, so we should be running it one more time, or we should be creating that index. So that should be fine, and let's go ahead and refresh. Okay, now we should be able to search Tiny, and sure enough, we get two data results, customer and orders, and these are the ones that we just created. And sure enough, they have all of the customer key, name, address, everything that we saw getting pulled up, and this is great. So now we can, star this. This is the table that I was actually looking for. I want to put, my email address. I'm the owner of this table, and so if you have any questions on this table, reach out to me because I'm the person who owns it. Oh, apparently I didn't save that, did I? Let's see, put that. Then we got to put add and then save and then refresh. There we go. Yep. So now we have, if we go back to the first page, you can have all your bookmark stuff. Anything as you have Amundsen running will start to show up in these popular resources files down here. Maybe these are tables that are constantly being searched, and this is stuff that will become more apparent as you've had Amundsen running and is kind of central to all of your data stores. All the people using these your common repositories and data stores. So ultimately, let me see if there's anything else. That should be pretty much yep. So you can also verify that all of that worked by looking at Neo4j, and so. Let me see, there's the password, test is the password. So you log in with test, and then you can also do one more quick verification step with this Neo4j query. I am not a graph data person, so I don't know this stuff off the top of my head, but I do know that it's basically querying over list of tables, and so we have order and customer that did get pulled in, and all the little data that's going around them. So anyway, so this is a basic overview, and I know it was a long-winded way to go through a basic thing, but there is a lot kind of to these pieces, but basic overview of what Amundsen is used for, how you would set it up and how you'd run it, and how you can kind of run through the demo yourself. Now that we kind of have this basic understanding, the real part for you to kind of dig in and play around with is, play around with this data builder framework. That's really the part that gets exposed to you that can ultimately get pulled out on this. And how we kind of glossed over how you would actually deploy this, but I ran it manually here in this page here, but then you would ultimately run this on like an Airflow or let's say some other type of scheduler like a Uzi, or just depending on what you use, or what's the some other scheduler that will run on this. I'm thinking NiFi, that's the one I had in my head. So any of these schedulers that can kind of basically run all of these ingestion pieces, that's ultimately where you'll pull this from. You won't be running scripts manually yourself, hopefully outside of just testing. So so that is Amundsen, that is the demo, and good luck. If you have any questions, reach out to me on trino.io/Slack, and you can basically just join our Slack channel and find me on there. I'm Brian Olson, and just search for me there. Ask me any questions you want about this, and I'll definitely help you out with it. Thank you.